Good morning, grade 7s, and welcome to another wonderful day of learning with WorksheetCloud. This is a grade 7 natural science lesson. If you have a question, please send an email to grade7@worksheetcloud.com. As I said, another wonderful day to learn something new. Today's lesson is heat energy and its transfer. Good morning. I am Mrs. Hall. So the objectives of today's lesson is to look at how heat flows through a solid by conduction. We are going to look at conduction in terms of vibrating particles. We're going to look at metals being good conductors of heat energy, and then we are also going to have a skills focus today where we are going to revise and recap variables dependent and independent. Right, so heating as a transfer of energy. Let's get started. So energy transfer is the movement of energy from one object to another. Thermal energy is energy produced by heat. Heat transfer occurs when there is a temperature difference between two objects or places. The heat is transferred from the hotter object or place to the cooler object or place. The heat energy transfer continues until both places or objects have the same temperature. Now, if you need to consolidate that or read through that on your own, press pause. Just pause me and read through the slide on your own, just to make it sink in. Okay, just in case I'm going a little bit too fast. So let's take a look at heat transfer by conduction. So conduction is a form of heat transfer in solids. It also happens in liquids and gases though, but occurs mostly in solids. It's between two objects when they are in direct physical contact. In other words, they are touching each other, and the heat moves from the hotter to the cooler object. Conduction can also occur in one object when the heat moves from a hotter part of the object to the cooler part of the object. And if you look at my diagram in the background, you have a little girl buying marshmallows, and she's holding a metal rod with a delicious marshmallow on the end. But you can see the heat source is the fireplace, and obviously the heat is going to transfer from the fire and move along the metal rod till eventually it will be too hot for her to handle or hold the metal rod. Okay, how does this happen? Let's find out. Right, so when heat travels by conduction, the particles near the heat surface start to vibrate. Now remember, I spoke about conduction occurring mostly in solids. So remember how particles in a solid are so tightly packed together. They don't move around, okay? They vibrate. Okay, so they're closely packed and they vibrate. These vibrations are then passed to the atoms next to them, which in turn pass the vibration through the material. So, as you know, metals are very good conductors, which is why a metal spoon will get hot very quickly when used to stir the contents of a pan. So if you look at this pan over here, the heat energy is coming from the stove. The transfer of energy takes place onto the pan. The pan gets warm, but then the metal spoon is also a good conductor, and that will also get hot through the process of conduction, and eventually you will not be able to even hold the metal spoon. Has that happened to you while you've been cooking, grade 7s? So let's take a look at a quick conduction experiment that we would have set up in the classroom. So we would have set up a clamp stand with 4 paper clips stuck onto a metal rod with Vaseline. You can see that over here, and the Vaseline has to be in equal amounts on each paper clip, and I will explain that to you later when we look at what makes a fair test. You would heat one end of the rod over here, the metal rod, you can see it with the Bunsen burner. you would heat that end and time how long it takes for each paper clip to fall off the metal rod. So you would set it up like this in the classroom. You would have your piece of paper with your paperclip number in table form like this, and you would time taken for each paper to fall off, generally in seconds. Okay, so there you have your experiment again. So the heat from the Bunsen burner has traveled along the rod by conduction. Can you explain what happened to the metal particles or the atoms to allow the heat to move through this metal rod over here from what I've already told you about conduction? Let's take a look. We can see the metal rod, okay? The thermal energy is being transferred from each particle to each particle by the process of conduction. Heated particles expand and vibrate, and they bump into the nearby particles, transferring heat to them. With time, the heat is transferred to the entire metal rod, and that, grade 7s, is why the paper clips slowly start to drop off. So, here you have it. One little particle starts to heat up, it vibrates, and it moves to the next little particle, vibrating, and so the heat continues to spread until eventually, ouch, you cannot touch that metal rod. So, what are the best conductors, grade 7s? Let's do another little experiment. We're going to place two different metal rods on a tripod stand, so they are touching at the end. I'll put up the diagram now. You are going to stick a paper clip on the end of each rod using Vaseline again, making sure that equal amounts of Vaseline for each paper clip. Heat the end of the rods where they meet and time how long it takes the paper clips to drop off. So here we have it. We have our tripod stand. Yes, remember these fabulous scientific laboratory apparatus that we used in the classroom all the time. And hopefully you remember these apparatus and you can imagine this happening in your head. Okay, so we have our tripod stand. We would have had a copper rod. We would have had an iron rod. This would be our heat source with our rods touching over there. Vaseline at each end, equal amounts with a paper clip at the end. And the objective of this experiment would to see which rod or metal rod conducts heat faster. Just think about it. Is it going to be the copper rod or the iron rod? What do you think, grade 7s? So we would have taken our two different metal rods, set up a table, and we would have timed how long for the iron rod for the paper clip to fall off and how long for the copper rod for the paper clip to fall off. And what do you think the results would be? Yes, you are quite right. It would be the copper rod, because the copper rod is a far better conductor and heats far quicker than what the iron rod would do. But that doesn't mean iron is a good conductor. It is. It just means that copper is better. Any idea what the best metal is for conduction? Does anybody know? It would be silver. Yes, silver is the best conductor. Okay, so the heat from the Bunsen burner traveled along both the rods by conduction. Can you explain why the conduction was faster in one rod and slower in the other? Okay, I just answered that question for you. Now, this is our skills focus, and for those of you who haven't looked at variables yet or haven't been taught it by your teacher, listen carefully and hopefully you will have a clear understanding. So we're going to identify variables that affect results. Now, variables are things that can change in an investigation. Variables can be seen and measured. Okay, so we observe them. Examples of variables would be mass, temperature, time, the type of material used, and the amount of substance that is used. So if you were pouring liquid into containers, the amount of substance in each container would be a variable. So when you plan an investigation, you choose one variable to change and you keep all the other variables the same. The variable you change is called the independent variable, which is also called the input variable. This is changed by the person conducting the investigation. Now, don't stress, don't panic, deep breaths if these are all new words to you. As I continue through my slides, it will start to make more sense to you. Okay, so the variable you change is the independent variable. It's also the input variable, and it's changed by the person conducting the experiment. The variable that changes in response to the independent variable being changed is called the dependent variable or the output. So the input is the independent, the output is the dependent. It is the thing that you measure or observe and is the result of the experiment. Okay, so let's go through this in a little bit more detail so that you can understand it a little bit better. So, as I said earlier, we have to make sure that any investigation we do in a science class is a fair test. Okay, and I have to share with you, often in my tests, I say to my classes throughout the years, was this a fair test? And a lot of children answer, yes, it was a fair test if you learned hard and you knew all the answers. But that's not what I mean from a scientific point of view. From a scientific point of view, I want to know, is it a fair test? In the sense that it is a test which controls all but one variable when attempting to answer a scientific question. Only changing one variable allows the person conducting the test to know that no other variables were affected or have affected the results of the test. So it's got nothing to do with how much you've learned or how much work you understand in writing the test, whether I set a fair test or not. Overall, it has to do with the investigation that you are doing. Okay, just thought I would share that for you. It's my little laugh for the day. Because a day without laughter is a day wasted. That is the motto in my classroom, grade 7s. Okay, so a fair test, you conduct one by making sure that you change only one factor at a time while keeping all other conditions the same. The variable you keep the same to allow to be a fair test is called the control. Okay, the control variable or the fixed variable. Okay, lots of new terms here. Dependent, independent, control, and fixed. Okay, you can always go back and watch my video, or you can pause these slides and read over the content yourself. Just let it sink in. So, let me go through this with you again. A dependent variable is always graphed on the y-axis, okay? And the independent variable is always graphed on the x-axis. Okay, so a dependent variable depends on an independent variable. Okay, I know it seems so confusing, but it's actually not. Okay, so here we have the y-axis. If you're graphing it, that is your dependent variable. Okay, and here you have your x-axis. That is your independent variable, grade 7s. Take a good look. Okay, remember your graphs? Your y-axis, your x-axis. Your y-axis normally goes up in equal increments, okay? and you plot what is moving up on the graph, and your x-axis is what you might be graphing for a specific thing. Okay, so y-axis is your dependent, and you're going to understand why now, and your x-axis is your independent. So let's take a look. So, as I said earlier, your dependent variable is your output, and it's always graphed on this axis over here, your y-axis. So if you want to know what is the amount on my paycheck, so you have a little job and you are waitering every day, what is the amount on my paycheck? And it's going to go up in equal increments, okay? That is your dependent variable. Well, that depends on your independent, which is your input. How many hours did you work here? For 1 hour, you might have earned 100 Rand. For 2 hours, you might have earned 200 Rand. 3 hours, you might have earned 300 Rand. Okay, as a student, I doubt you're going to earn that much, but there's always hope. Okay, so basically, your amount that you earn depends on the number of hours you work, which would be graphed over here on the x-axis. Look at your price of a speeding ticket for your moms and dads, okay? If they're speeding, that is the dependent, that is your output over here, okay? It depends on the speed they were traveling. So if they were 10 kilometers over the speed limit, they might only pay 100 Rand. If they were 20 kilometers over the speed limit, they might pay 200 Rand. Do you understand? Example, another one. The dependent variable, the height of the grass. How high is the grass growing if you measure it over here? Okay, on your y-axis depends on how much rainfall we had. So it could be in millimeters along the x-axis. Speed of a car on the y-axis, your output, depends on your independent variable, how much pressure you apply on the gas. So the further you push your foot down on that accelerator, the faster your car will go. And my best example, and I love to use this in my class, is my yearly mark in Mrs. Hall's natural science class. If you want to be at 100% up here at the top, okay, on the y-axis, you want to reach 100%. That depends on your independent variable, which is your amount of effort you put in the class. Okay, so how much effort are you putting in? How much time are you putting in? Okay, you measure it on the x-axis, you put it down as the independent variable. Do I spend 1 hour a day, 2 hours a day, 3 hours a day? The more time you spend, the higher your mark will be. Okay, I hope you understand, and I hope I've made it a little bit more simple for you, and you now understand the difference between a dependent variable and an independent variable. So, good conductors in the home, now that you know what conduction is and how heat is transferred through the process of conduction in a solid, you know that stainless steel, which is mostly iron, is a very good conductor of heat and is used to make pots. Okay, I want you to think, grade 7s, can you think of any other items in your home that are good conductors? Now I want to put something in here, a little bit of a reminder for you about what stainless steel is. Remember, we did this earlier in one of our earlier lessons. It is an iron alloy with added elements. Okay, remember what an alloy is? Made up of 2 or more elements, such as chromium, nickel, silicon, manganese, nitrogen, and carbon, all added to stainless steel. The properties of this final alloy can be fine-tuned by altering the amounts of the various elements. Okay, so stainless steel is an iron alloy, mostly iron, used to make pots so that you can cook your food and the heat can be transferred from the stove to your metal pot through the process of conduction. Right, just another little recap. Wood is a poor conductor of heat, and it's very important that we have poor conductors of heat as well. For example, in winter, which is fast approaching, we want to have insulators on in our everyday life. Do you know that your jersey and your tracksuit top is an insulator? It doesn't allow the heat to move from your body outside into the air. So it traps your heat inside your body and it keeps you warm. Okay, so that's just an everyday example you could think of. We tend to use wooden spoons in cooking since they won't pass the heat through them onto our hand, and we call wood a good insulator. Okay, so we don't want to get burnt while we're cooking those delicious pancakes that you're all busy cooking during this lockdown. What are the best insulators? We can do a quick little investigation. We place 3 different rods, metal, plastic and wood, into a beaker containing freshly boiled water, and after 5 minutes gently touch the end of each rod and find out which ones are hot or cold. Which one do you think will be the coldest? The metal, the plastic or the wood? Okay, there you have it. And let's take a look exactly how we would have set it up in class. We would have said what rod we had and is it hot or cold after 5 minutes, and we would have said which was the better insulator. In other words, which rod did not allow the heat to travel through it. And remember, insulators are important. Okay. The heat from the Bunsen burner has not traveled along the rods at the same amount during the same amount of time. Can you explain what happened to the particles in the insulators? They didn't allow the heat to move through them. Okay. So, quick quiz to see just how well you've been listening, and there might be some incidental learning here, something you might not have known before, but you will learn it now. What is temperature a measure of? How can you make the temperature rise? And what is the difference between heat and temperature? Okay, so temperature is a measure of how hot or cold something is. How can you make the temperature rise? Well, that's easy. You add heat energy. And what is the difference between heat and temperature? Oh, I've disappeared there. Heat is the energy. Temperature is how hot or cold something is. Okay, grade 7s, here's a quick last minute little exercise for you. I want you to put these statements in order, so you're going to read through them. You can pause me here, and then you're going to put them in order. What happens first, what happens second, what happens third. Okay, so pause me and quickly write it down. What happens first, second, third, fourth, and fifth. Okay, I'm going to give you the answers now after you finish pausing me. So firstly, we are going to say heat makes the particles vibrate. The particles in the solid are tightly packed together, so the neighboring particles also start to move. Okay, and then what happens? The heat can therefore travel. The movement means that, the movement means I missed one. The movement means they have a higher temperature, number 4, and then the heat can therefore travel along the solid. So number 1, heat makes the particles vibrate. Number 2, particles in the solid are tightly packed together. Number 3, the neighboring particles also move. Number 4, this movement means they have a higher temperature. So number 5, the heat can therefore travel along the solid in the process of conduction. Quickly answer these questions. Conductors in the home would be your electric iron and your saucepan, and insulators in your home would be pot handles, clothes, and that's why you wear a jersey in winter, to insulate you and prevent your body heat from escaping. Thank you for watching, grade 7s. I sincerely hope you did learn something new today and that you enjoyed this lesson. Just remember, this worksheet was brought to you by WorksheetCloud. Please remember to download your homework sheet and get busy on that. See you soon, grade 7s.